Okay, in this problem, we're going to construct a mathematical model that gives the volume of a box that we create by taking a rectangular piece of cardboard that's 34 inches long by 28 inches wide, and then we cut out from each of those corners an x by x square. And after we cut out those corners, we're left with a piece of cardboard that looks like this. And when we fold these sides in, we create a box. And we want to find the volume of that box in terms of the variable x. So let's start by labeling the unknowns up here. So I'll call this side the length of the box that we create. I'll label it L. And this side here will be the width of the box. And then this will be the height of the box that we create. Right? So we create this box, and the volume of the box that we create, remember the volume formula, is the length times the width times the height. Right? There's volume written as a function of these three variables. We want to write it as a function of just x. So we have to figure out, is there a way for us to rewrite each of these variables in terms of the variable x? I'll start with what I think is the easiest one to see, and that is, how do I rewrite h in terms of x? Right? Well, h, the height of that box, well, that's the size of one of the sides of the square, right? This is h right here, so h is equal to x. And so I'll put that. H, we can rewrite as x. And now let's deal with the length. Right? So to see how we can rewrite this variable L in terms of x, let me pop back over here. Right? So this side is 34 inches long. And look, it's made up of a little piece that is x inches long, and then another little piece that's x inches long. And then this piece right here, that's L. Right? This is the x and the L and the x. So x plus L plus x plus L plus x is 34, right? It's 34 inches long. So L plus 2x equals 34, which means L equals 34 minus 2x. And we can do the same with W. If I go over to this side of the rectangle, it's 28 inches long. Right? It's made up of a piece that's x inches long, and then another piece up here that's x inches long, and then this piece right here, that's W. So x plus W plus x is equal to 28. W plus 2x equals 28, which means W is 28 minus 2x. Okay, now we can take these expressions for each of these variables, drop it back into our volume formula, and we're left with a function in the terms of the variable x. Its length, which is 34 minus 2x, times width, which is 28 minus 2x, times the height, which is x. There's the volume of the box written in terms of the variable x. And then the question also asks us, what's the domain of this volume function? Okay, so without any context, if I had just said, what's the domain of this function x, and I don't say anything at all about what x represents, the domain of this function would be all real numbers, right? It's a third degree polynomial. There are no trouble spots. X can be anything. In the context of this problem, x has a particular meaning, right? It's the side of this square. So to figure out what the domain is, the restrictions on x, the physical restrictions on x here, keep in mind that each one of these expressions represents a dimension. It's a side in a box. This is the length of the box. This is the width of the box. This is the height of the box. So these can't be negative, right? Get some board space. So x has to be greater than or equal to 0. I'm going to allow x to be equal to 0. If x were equal to 0, it means I just didn't cut anything out. And so my box would have a height of 0. It would have a volume of 0. But it can't be negative. So x has to be greater than or equal to 0, and 34 minus 2x has to be greater than or equal to 0, and 28 minus 2x has to be greater than or equal to 0. All three of these have to be satisfied. So let's solve them and then find the x's that satisfy all three. Okay, well, no problem with this one. X is greater than or equal to 0. So this one here, I'll solve this linear inequality. I'll add 2x to both sides. And then divide by positive 2. So what is that? 17. X has to be less than or equal to 17. Doing the same on this one. Add 2x to both sides. Divide both sides by positive 2. X has to be less than or equal to 14. Okay, so x has to be greater than or equal to 0, and it's got to be less than or equal to 17, and it's got to be less than or equal to 14. So the x's that satisfy all three of these are all those x's that are greater than or equal to 0, and less than or equal to 14. Right? 15 does not satisfy this, right? 15 would satisfy this one, 15 would satisfy this one, but 15 doesn't satisfy this one. So the domain for this problem is x has got to be between 0 and 14 inclusive.